Hey guys, the purpose of this video is to give you an example of how to graph your data. And we are going to graph the first set of data, and that is how does mass affect motion. So we're going to be focusing on the first set of data, and then you guys are going to do something very similar, but on your own, do the experiment number 2. But most of this stuff will be the same. Just applying the points will be different. All right, so first we have to make our graph. And you'll see on this right side that I already have some stuff labeled, but we're going to change what that is. This is just to remind you that the independent variable goes on the x. Remember, the x marks the spot of the treasure, so it's on the ground. And then the y, YMCA, goes up and down. That's how I remember it. And the dependent variable is on the y, and the independent variable is on the x. But first we need to make our axes. So you guys will be using your handy dandy pencil, but I'm going to be using this line feature because I can't draw a straight line with my mouse. Look at how wobbly it already is. And then we have that line for our y, and then our x. Now one of the big questions is, how high up do you have to go? Well, if you look over at our data, so over in our averages, because those are what we're going to graph, you'll see that we range from 37 to 87. So 37 is close-ish to 0, and 87 is close-ish to 100. So we're going to go from 0 to 100 on our y. So obviously we don't have 0 to 100 boxes, but we can count by tens. So we only need 10 boxes, and you'll see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it ends up, for my example, being perfect. Your graph paper, well, plenty of room. All right, but before we start putting that in, let us label our axes. So instead of having dependent variable, we are going to put distance car traveled. So I'm actually just going to be lazy and just copy and paste it. Ooh, and then you can't even read that. So let me make that bigger for you. Right, bigger still. So distance car traveled, that's our dependent variable. It's what we measured. And our independent variable is going to be the mass of projectile, and we change that by the amount of water. And you may be asking, do I really need to put like the centimeters or the amount of water? Because that's how we measured it, yes, because then that saves you time in the long run, because then you don't have to label each thing down here. So when we for example, when we label the distances, we don't have to say 0 centimeters, 10 centimeters, 20 centimeters. We'll just put 0, 10, 20, 30, 40, because the centimeter is already labeled. Alrighty. And now we're going to finish putting in our numbers here. So as I said, we're going to go from 0 to 100. I failed at scribbling, so that's why I have all these text boxes. You would be writing these, but you'll see that I'm trying to put them on each line. So not in the middle, but on each line. I grabbed the 50. I'll probably skip ahead and have this done. That way you're not just bored watching me do this. Or you could leave it going. Oh my goodness. Undo. Redo. Alright, I'm happy again. 60, 70, 80, 90, Last one. 100. Alright, so that's our distance. But then we still have to label our x. So we need, over here you'll see that it was empty, half full, and full. So that's where this came from. So we're going to put empty here, half full, and I should really not filled, the full. Might as well make it match. Alrighty. So now we are on to actually graphing. So plotting the points. So the reason this is probably different than math, you may know how to plot points when it is like 1, 3, and you have a 1 and then a 3, and you just match that up. But what do you do when you have 37? We'll see our data is 37, but there's no 37 on this line. So it's actually pretty simple. You know that 37 falls between 30 and 40, so you're going to put it in between there. And you know that 37 is a little bit more than half, so you're going to go just a little bit above the halfway point of 30 and 40. So we're going to make a bar graph, and it will look something like this. So let me get shape. So this was for our empty. You see empty, and our average is 37. So you guys will be drawing this in. I'm gonna use 2 squares. So there would be about 35. So I need to go just a little bit above that. Boom. So then you would shade that into your boxes. And now we're gonna do the next one. So half filled, see half filled is 66. So we're going to go find a half filled. I'm pointing with my finger like you can actually see that. And then 66 is a little bit above halfway again. Oh, I went a little bit below. Luckily for me, I can just do the quick edit. And our last one, our full, went to 87. And shapes. So full, we have to go all the way up to 87. So there's 80. So I need to go, there would be about 85. So 87 would be about there. So it's not exact, but you can definitely tell it's not at 90, and it's definitely above the halfway point. All right, we are almost done with our graph. We are going to just need to add one thing, and that's a title. Now in science, you don't get to make like fun little names of stuff. I'm sorry. Scientists like to be very straightforward. So for this, you usually just use your independent variable and your dependent variable to help you explain what the graph is. Oh, check out my science mug. Look at all those equations. Sorry, I got distracted with my coffee. All right, so we have to describe what this graph is. And again, you would handwrite this, but I'm going to type it out. So we have the mass of projectile affecting the distance the car traveled. So I would say something like how projectiles mass affects car's distance. And that is about it. Just making it a little bit bigger so you guys can see it. And title goes up at the top. And then we have our done graph. Go us.